Hello guys, welcome everyone to my channel Chemholic. And so guys, we all know that these times are very sensitive as well as crucial because of such an outbreak of COVID-19 virus all over the world, and I know your studies are also getting affected at the same time. But you don't worry, I'm trying my best to bring out the best course for you guys to keep your pace up. I hope you guys enjoyed my previous video, so let's continue with the same spirit and start our first chapter, chemical reactions and equations. Guys, we are studying chemical reactions and equations, and today we are going to start with balancing of chemical equations and how the equations are actually written down. So we will be taking examples to understand this concept, and but before that, balancing of chemical equations, we need to learn how the chemical reactions are actually written. So guys, you see the word equations are written like this. You can see here magnesium, oxygen, they both are reacting and they are forming a magnesium oxide product. So we have this magnesium and this oxygen on the left hand side, and this magnesium oxide, it's there on the right hand side of the equations. Also we see an arrow between them. This is the arrow, and as we see the previous equation, we'll understand this terminologies through this equation itself. So reactants are actually the ones which are written on the left hand side. So guys, this is your left hand side, and these are the reactants which are written on the left hand side of chemical equations, and the product are the ones which are written on the right hand side of the chemical equations. Also, if we have more than one reactant present on the left hand side, then we use this plus symbol. You can see the plus sign here, and we use this plus sign to show that these two reactants, that is a reactant, these two chemical species, they actually get combined and they form this product. So guys, this is the product which is formed by the reaction of magnesium and oxygen. The arrow between them, it shows the direction of the chemical equations. That means the reactant actually react together and they form the product in the end. So guys, now you know how we write the chemical equations. So a chemical equation, it's represent a chemical reaction, and so here we'll start with taking an example, which is Mg reacts with O2 to form MgO. It's all called a chemical equation. And but how do we know that whether it's balanced or not? Whether this equation is balanced? But how do we know that whether it's balanced or not? Whether this equation is balanced or not, and what do we mean by this balancing? So let's try to understand this particular thing. So the first rule is count and compare the number of atoms of each element on both sides. So guys, now you see that this is the equation we have, and the first rule says that we have to count and compare the number of atoms of each element on both sides. That means left hand side and right hand side. So we can make a table where we can write all these things. So we have written element and you see left hand side and RHS we have written, right hand side. We have also written all the elements which are involved in the equation. We see only two elements are actually involved in the chemical equation, that is magnesium and oxygen. We have written their symbolic form here. So left hand side, and on the right hand side we have this MgO. So only one oxygen is there, so we'll write here 1. So guys, this is the first rule that we saw. So we saw here the number of atoms of magnesium is actually same on both sides, but the number of atoms of oxygen, it is not same. You can see the difference on the LHS and RHS, and magnesium is equal. Okay, it is equal, but the oxygen, it is actually not equal. So the number of this oxygen element was not same. If the number of unbalanced elements are not equal on this side, called as unbalanced equation. And also it is also called as the skeletal. In other words, it is also called the chemical reaction. So guys, skeletal chemical that the equation that basically we balance the previous slide. The magnesium reacting with oxygen, and need to balance MgO. It was since the number of the need element, that law of this oxygen element is that works same, so it is unbalanced. And what this equation is conservation of called as says unbalanced equation, and also it is also called as the skeletal. In other words, it is also called the skeletal chemical phenomena occurring in our surroundings. Skeletal equation, but what is the need to balance them? So the need is the law of conservation of mass that works behind this concept. So what does this conservation of mass says? It says that mass can neither be created or nor be destroyed in a chemical reaction. That means in any kind of chemical phenomena occurring in our surrounding, mass can neither be created nor be destroyed. That means the mass of the reactants should be equal to the total mass of the products in a chemical reaction. So guys, chemical phenomena which is occurring in the nature, and since nature follows this law of conservation of mass, so the total mass of the reactant has to be equal to the total mass of the product. This is the reason why we balance the chemical equations. Since the number of atoms of each element remains the same before and after a chemical reaction. So the number of atoms, mass is equivalent to number of atoms. So number of atoms are not equal in case of unbalanced. So we need to balance them and we need to make them equal. So how do we do that? So let's start with the balancing of chemical equation. So guys, let's start with chemical equation. Taking an example, so here we have a chemical equation. We have this H2S and this O2. They are reacting to form H2O and SO2. SO2 is sulfur dioxide, H2O is water, it is oxygen gas, and this is hydrogen sulfide gas. So guys, this is first we have to see whether they are balanced or not. So for that, follow the steps. So what are the steps that we need to follow? We'll go step by step. We'll write the skeletal equation. And the first step is make a table for skeletal equation. So guys, as I showed you before, how do we make a table for the skeletal equation? How do we write the number of atoms of each element on both left hand side as well as right hand side? So we'll make this table, and we'll write the elements in this column. We'll write the atoms of each reactant on the left hand side and on the right hand side. So here we can see easily which element is actually not balanced. We will start with hydrogen. So hydrogen is one of the element. So we'll see on the left hand side how many hydrogens are there. 2 in the subscript that shows 2 atoms of hydrogens are there. So we'll write 2 here. Then we have on the RHS side, again this side no H, but here we have this 2H again. So we'll write 2 on the RHS side. So guys, this is the 2 we'll write here. Now we'll start with sulfur. We'll take another element, sulfur. So sulfur is and we'll write only those elements which are actually involved in the chemical equation in this table. So we'll go to the sulfur. Sulfur, we have this only one sulfur is there. So we'll write 1 on the LHS side. Then on the RHS also again 1 sulfur. So we'll write 1 here. Now we'll go to this oxygen element. So we have this O2, again 2 atoms of oxygen, and this here we see 1 plus and this O2, that means 2 plus 1 it becomes 3. So this is the first thing. While balancing chemical equation, we need to make a table which shows us which element is actually not balanced. So we see the hydrogen, both sides number of atoms are equal, so it is balanced. Now we go to this sulfur, both sides the number of atoms are 1, that means again balanced, so no need to balance them. Now we'll move to oxygen. So here we see 2 atoms of oxygens are there on the left hand side, and 3 atoms of oxygens are there on the RHS. That means they are not balanced. So first we'll write the skeletal equation. Compound, as we see, it's this one compound and this again 2 compounds. We see this is an oxygen molecule, and so we'll start with the one which is having the maximum number of atoms. So actually all the 3 compounds are actually having the similar ones, so we can take any one. We'll start with this H2S. So here we see the number of oxygen atoms are not equal, and what do? We'll make it equal by putting coefficient 2 on LHS to O2, and similarly to on RHS. If you see oxygen on the LHS side, it is 2 atoms and here 3. So how will make it equal? When we are balancing any chemical equation, we never write any coefficient in the subscript. What is the meaning of coefficient? Coefficient itself is written before any digit. So here we have this compound or any molecule, it's our digit, and we write the coefficient in before that. We never write in the subscript. So 4 oxygen atoms are there on the LHS side, and this 2 plus 2, this 2 and this 2 into this O, it becomes 4. So it becomes 4 here. So we see that the number of atoms of oxygen on both sides are now become equal. Here also I can write 4. So both of the oxygens are now equal on both sides. But the problem is, since we have multiplied or written the coefficient 2 here, it is also having this H2. That means this H2 now becomes 4 on the RHS, and this on the LHS. It is balance the other elements by putting the suitable coefficients. So we'll write the equation. Since we have written the coefficients 2, we'll write that. But now we know that this number of hydrogen atoms on RHS, it becomes 4, and I have also written 2H2O to show you that you don't get confused. And at LHS also it has 2 H2S. It is the name of the compound. So guys, 4 on this RHS and 2 on LHS, they are not balanced. So balance it. So what we'll do, we'll make it equal by putting coefficient 2 on LHS to H2S. That means if we have 4 here, and we have 2 here, what is the simple thing that we need to do? Just multiply here 2, it will be equal to 4, so that they will be balanced. So we get this type of equation. So by just simply putting 2, that means it makes it 4, and here also it is nothing we wrote, so it is 4. That means now the number of hydrogens on both sides, now they are we put the coefficient 2 here, and here nothing was added. So we have this 2 sulfur here, and we have this 1 sulfur here. That means what we have to do, just if you place this coefficient 2 in front of SO2, it will be equal. So this SO2 will be equal. So we'll just put coefficient 2 to SO2. So we get this type of equation. Now you know that since the number of sulfur atoms are now become equal, so again, since it is also having this oxygen, now count the number of oxygen again. So it becomes 4 oxygens here, and 2 here, and 4 again here, and that's it. That means it is having this, if we will add these 2, so it will be 6. So 6 oxygen atoms are there on RHS, and 4 oxygen atoms are there on the LHS side. What do we do now? We'll make it equal by putting, we have 4 here, we have 6 there. What we need to do, since we have this 2 here, so anything which we write over here, O2 guys, on this subscript, if we think logically, if we put any coefficient, it will be first multiplied with this. When it gets multiplied with this subscript 2, it becomes equal to 6. So it will be balanced. Guys, one more important note for all of you. Any coefficient, if it is written before any compound or any molecule, it actually get multiplied with the subscript. Okay, it is not added, it is multiplied. So another note for you guys to avoid making any silly mistakes. So we'll again write the equation. So we have written 3 over here. Now count again all the number of all the elements. So we can see we'll start with the hydrogen. So we have this 4 hydrogens here on this side, and we have this 4 hydrogens here equal. So no worries. Now we'll go to sulfur. This sulfur, now it is 2 here, 2 sulfur, and we have this 2 sulfur here. Okay, and we have, so it is also equal. So now we'll move to the oxygen. So it is 6 oxygen and 2 oxygens here, 2 plus, and this 2 into 2. So subscript is only applied to oxygen, not sulfur. Okay, those 2 multiplied by 2, it makes it 4. So 4 plus 2. This is a balanced chemical equation. So I'll show you the final balanced chemical equation. So guys, this is how we balance the equation, and simply we went step by step. So guys, always start slow. Okay, with time you will catch up speed, but in the starting when you are beginning to balance any chemical equation, always go slow, always make table to write the number of atoms for the skeletal equation, always count at each step which element is not balanced, and you know the simple rule, you just have to make it equal by writing the coefficient before any compound or molecule. So this is very simplest way that you can balance. I hope you guys understood the balancing concept. So guys, thank you so much for watching. If you don't want to miss out any of the information shared at this platform about chemistry, don't forget to subscribe my channel Chemholic. Also like it and share it with your friends. Join our community Chemholic. Stay motivated, stay positive, because we have got Chemholic.